experience important adjustments and settings. Troubleshoot and diagnose faults in the transmissions. Click Next to continue into transmission system to proceed. The purpose of transmission in any vehicle is to transfer the power produced by the engine to the wheels. The engine operates at predetermined parameter, and the power produced is continuous. The torque and the speed of this power need to be changed as per the needs of the driver, so that the movement of the vehicle is smooth and uninterrupted at all times. Transmission does its purpose of not only transferring the engine power to the wheels, but also with torque conditions, and reverse the direction of the rotation for reverse gear. Transmission also permits use of engine power to drive accessories like hydraulic pump into per application through power takeoff gearbox. Click on image to know more, and then continue.
Efficient, manual or automatic transmissions. Often, transmission refers to a gearbox that uses gears to provide speed and torque relations between input and output. First, let's have a quick look at the basic principle of transmission. For that purpose, a very simple 2-speed gearbox will be explained. 2 gear wheels are machined into the output shaft. The other 2 wheels are mounted on a spline shaft. These 2 wheels can slide from left to right and from right to left to change gear ratio. In first gear, the gear ratio is 2 because the driven gear is twice as big as the driver gear. Consequently, the input speed of 2,000 rotations per minute is decreased to an output speed of 1,000 rotations per minute. Shifting from first to second gear in this transmission is only possible when the engine stops. Then, shifting of gears is possible. In second gear, the input speed is increased because the gear ratio is 0.5. Because gear shifting is complicated for these kinds of transmissions, synchronized manual transmissions were developed that allow to easily select and deselect the gear, even when the vehicle moves. In modern cars, 5-speed or 6-speed transmissions are usually used. Here, however, a very simple explanation is given with the help of a 4-speed transmission. The input shaft is connected to the engine. The rotational energy of the input shaft is transferred to the counter shaft that transfers its energy to the gears of the output shaft. The output shaft is connected to the wheels of the vehicle. The power flow between input shaft and engine can be adjusted through a friction clutch. The gear wheels of the input shaft and the counter shaft are fixed to their shafts. They rotate when their corresponding shaft rotates. However, the gear wheels of the output shaft are not fixed to the shaft and can freely rotate. Locking a gear wheel to the output shaft is possible through a dog clutch. Here, a tooth system is fixed to the shaft. To shift from neutral into first gear, a part of the dog clutch slides sideways. But first, the friction clutch has to be disengaged, so that the engine does not transfer the mechanical energy produced to the transmission. The friction clutch can be engaged by the driver as soon as the dog clutch is fully engaged. Through the counter shaft and the output shaft to the wheels, so the vehicle begins to move. When the driver wants to shift from first gear to second gear, he or she must disengage the friction clutch. Then, the driver can shift gears without damaging the transmission. Here, the tooth system of the second gear and the tooth system of the output shaft will be synchronized to correctly match the speed of the gear to that of the shaft as the gear is engaged. When the friction clutch is engaged by the driver, the energy is transferred to the transmission and, consequently, to the wheels of the vehicle.
Or wheels. In rear-wheel drive vehicles, the transmission is located in between the clutch and the propeller shaft. This type is used in almost all trucks and heavy vehicles. In front-wheel drive vehicles, it is part of the drive axle, means the transmission and the drive axles are housed in one shell called the transax. The transmission is attached to the engine by means of clutch, which is in another device to momentarily connect or disconnect the power to the transmission from the engine in manual transmission-equipped vehicles. Click Next to continue. Transmissions can broadly be classified into following types. They are manual transmission, automated manual transmission, automatic transmission. In manual transmission, the driver has to change the gears manually as per the speed and torque requirement. An AMT is composed of a dry clutch, a gearbox, and an embedded dedicated control system that uses electronic sensors, processors, and actuators to actuate gear shifts on the driver's command. But in automatic transmission, changing of gears is done automatically as per the speed and torque requirement. Only reverse gear has to be put manually. Let us learn more about the manual transmission and their types and AMT in this chapter. Click Next to continue. System, manual transmission. Manual transmission again can be classified into three types based on the types of meshing of gears. They are sliding mesh, constant mesh, synchro mesh. Click on each image to know more.
We know that the gearbox are mainly of three types: sliding mesh gearbox, constant mesh gearbox, and synchro mesh gearbox. Now let's discuss the sliding mesh gearbox in detail. Sliding mesh gearbox consists of an input shaft, a counter shaft also known as lay shaft, and an output shaft. The input or clutch shaft has a spur gear attached to its end, known as clutch gear. This clutch gear is meshed with a gear on the lay shaft. Other than this gear, the lay shaft has three more spur gears of different sizes. The gears on the lay shaft are fixed to it so that whenever the lay shaft rotates, all the gears rotate with same RPM. The splined output shaft has two different size spur gears mounted on it. These two gears are mounted in such a way that they rotate with the output shaft, but can slide horizontally along the splines of the output shaft. Now let us understand its working. The power from the engine gets transmitted to the clutch gear through the clutch shaft. The clutch gear, being in mesh with the lay shaft gear, starts rotating the lay shaft. This in turn rotates all the gears of the lay shaft at same RPM. Now with the help of a selector mechanism, the gears on the splined output shaft are moved left or right to mesh them with appropriate lay shaft gears and achieve the required speed. See the gear arrangements for different gears. Let us number the gears 1 to 8. Now to achieve the first gear, the gear number 6 is slid and meshed with the gear number 5. Now the power from the clutch shaft gets transmitted along the gears 1, 2, 5 and 6 to the output shaft, smaller than the gear 6. This reduces. Now let's discuss the constant mesh gearbox in detail. Constant mesh gearbox constitutes of an input shaft, lay shaft, and an output shaft. The input or clutch shaft has a helical gear attached to its end, known as clutch gear. This clutch gear is constantly meshed with a helical gear on the lay shaft. Other than these gears, several other helical gears of different sizes, that whenever the lay shaft rotates, the gear rotates. Whereas the gears on the splined output shaft are mounted on bearings, so that they can rotate independently of the output shaft. Each output shaft gear also has teeth on one of its side faces. Each of these output shaft gears are constantly meshed with one of the lay shaft gears to form a gear pair. And each gear pair represents one gear that the driver selects. Sliding dog clutches are also provided on the output shaft to select the driving gear for transmitting the power to the output shaft. These dog clutches are mounted in such a way that they can't rotate independently, but can slide on the splined output shaft. Now let's understand its working. The power from the engine gets transmitted to the clutch gear through the clutch shaft. The clutch gear, being in mesh with the lay shaft gear, starts rotating the lay shaft. This in turn rotates all the different size gears on the lay shaft at same RPM.